that can be used for multiple use cases. So without further ado, let's get started. So the first thing that we want to talk about in this whole hackathon event is what is a coprocessor? Why do we need it, right? That is the first thing that we want to touch upon. The second thing is, how would you choose a coprocessor? There are multiple kinds of coprocessors out there. And then we will dig a bit deeper into Oyster, which is the Marlin's coprocessor. Then we'll touch upon the bounties, resources, and any support that we offer. Okay, so let's get started. What is a coprocessor? Why do we need one, right? So a coprocessor at a high level is nothing but think of it as an additional machine that helps you to generate more compute power, right? And why is it useful? Because A, it will unlock a lot of capabilities that you won't be able to do it otherwise. Think of your phone, which used to have a single chip, right? And for a long period of time, we were able to do very small activities. But with the invention of new additional chips, now we are able to do much more advanced systems, right? So think of your coprocessor in a similar way, which will unlock new capabilities, and they also make some of your systems cheaper. Some of them might be performance oriented and will also unlock a lot of new capabilities, right? And pretty much they are upgradable, right? They have very little to no prerequisites if you want to scale them linearly. Now, just jumping to the next one, we defined what a coprocessor is. Now we want to discuss why do we need one, right? We're happy with the way things are, right? Why do we need one? Because A, we were actually not happy with the way things were, right? Especially in case of blockchain, the L1s are super expensive. It's close to impossible to run heavy workload complex tasks, right? And then second thing is, you may debate that, okay, L2s are here for that, but ultimately L2s are also smart contracts. They also have limitations, right? That's where coprocessors comes into picture. They help you with bunch of opening up a lot of possibilities and opportunities. Some of them being, you should be able to access data from archival blockchain data, right? You should be able to access Web2 data. You should be able to pass on to Web2 APIs, whatever that you have built in, right? And then you should be able to run long-lasting servers, right? It's not a point in time only, but you can also run something like your websites, you can host them. So yeah, all of those possibilities. And the important thing is coprocessors are generally circuit agnostic. That means as a developer, what we care about is we don't want to learn a new language just because there is a requirement, right? So you want to build on top of what you are familiar with. You just want to tweak a bit here and there, but you don't want to sit and relearn the whole flywheel again, right? So hence coprocessors, right? Now jumping directly into the different kinds of coprocessors. So these are the three kinds of coprocessors that exist in the market today. So you have ZKML, you have TEML, you have OPML. In terms of speed, we have seen that both TEML and OPML are fast. ZKMLs are in general slow, depending on the compute that you have been executing. In terms of confidentiality, Ts offer both model as well as your private inputs, right? Given that it's a secure enclave, everything is a black box out, so no one is able to access what is happening inside. Versus in ZKML, you do have an option, but either you can make your model private or you can make your inputs private, not both. And in case of OPML, it's generally everything is public, right? And in terms of finality, TML is immediate, ZKML is also immediate, but OPML generally have a 7-day contesting period, right? There has been debates that, okay, we can reduce this further, but yeah, again, the finality is not instant. Imagine you trying to do some P2P payments. You can't wait for not even 10 minutes, right? You want all of this to be pretty much instant, right? And then in terms of price overhead, this is where TML actually shines a lot. It's anywhere between 10 to 50% higher compared to your traditional compute. Versus on the OPML side, it's about 500%. And on the zkML it is 10,000%. Just because the kind of compute that is required, the cryptographic security that is required, it's super expensive. And on OPML side, it's expensive because there is a whole fisherman concept. Someone needs to check and verify whether everything is, whatever is submitted to on-chain, is it true or not, right? But in case of TML, you don't have to do any of this, right? I hope everyone knows what a TE is. TE is a trusted execution environment. Think of it as a secure enclave. The generic examples are Intel SGX or AWS Nitro enclaves and NVIDIA confidential computing. So yeah, just to name a few. In terms of security, TML offers a hardware-based security. That means you are trusting the hardware provider itself in terms of Intel, AMD, or your AWS or NVIDIA. So that's one limitation. Whereas in zkML, it's totally cryptographic. So you know that whatever the ZK proof has been generated, you can be rest assured that it has been done the right way. And in terms of OPML, like we spoke earlier, it's a concept of fisherman plus cryptography. And in terms of suitability, where is TML suitable for? TML is suitable for all kinds of models, be it small, large. Fun fact, we are able to run Llama 2 and Mistral on TML, right? So zkML, at this point, the way it is, it's only suitable for smaller models. Probably you can run a tiny Llama maybe, but yeah, no one has tested it yet, right? And in terms of OPML, it's pretty much dependent on how the protocol has designed the proof, the fraud and the proof of design, right? So yeah, moving on, introducing Oyster. So far we have covered what is a coprocessor, why do we need one, and we also benchmark different kind of coprocessors. And based on this, we realized that TML is the way forward and will be useful for about 80% of the use cases, right? Not saying that the rest won't be useful, but they are for very specific use cases, but TML is one of the approaches which can be used for about 80% of the instances. So yeah, introducing Oyster, a TML-based coprocessor. So what does Oyster does, right? It's a decentralized node of operators. So everything, any compute that you are offloading on off-chain, it is being executed by a decentralized node of operators. Then we do have all of DevOps tools inbuilt, right? You don't have to do anything, right? For example, auto-scaling, fault tolerance, all of those things are inbuilt. Web 2 applications can also directly use Oyster. Think of it as a supplement to your AWS or GCP. And you can work with any language. Like I said earlier, these are pretty much circuit agnostic. If you are a developer who prefers writing code in Rust, just do it, right? You don't have to relearn and do things, right? And yeah, you can access Web 2 APIs. And right now, Oyster is deployed on both Arbitrum and Polygon. But yeah, we are pretty much chain agnostic as well. We can pretty much scale to all the chains, and we are circuit agnostic as well. So yeah, some features of TEs that we spoke about. What does this TEs entail? These are secure enclaves. They provide hardware level isolation and memory encryption so that even the host machine where the code is running, they won't be able to access any of the code. That's one. And second thing is encryption is possible at both storage as well as network level while compute and also while in rest. You would be able to encrypt information. And third thing is it's pretty widely available, right? So and easily scalable as well. You have providers from Intel, AMD, NVIDIA. So yeah, they are cheap, fast, and infinitely more scalable. So how Oyster works? So in case of Oysters, we have two approaches. One is a serverless approach, and one is a server-based approach or an instance-based approach. In case of serverless, you don't have to rent an instance or do anything. You can directly use the functions without you have to renting an instance. The only limitation though it's based on WASM or JavaScript at this point. However, on instance side of things, everything is possible, right? You literally take your code, you package it as an enclave, and then you make it public on a any IPS or a decentralized storage, and then yeah, you pretty much deploy it, right? So it's pretty straightforward in terms of using Oyster. Irrespective of whatever code you have, all you have to do is you have to build it into an enclave. We have tutorial available for it. We also have tutorial in terms of how our team was able to run the whole Llama 2 inside an Oyster, what are the limitations that we have faced during that. But yeah, for this hackathon, we'll be limiting the whole approach towards instance-based only for simplicity. But yeah, you are happy to explore other approach of serverless as well. How to access? Like I said, there are both options available via smart contracts as well as Web2 APIs. Via smart contracts, you just relay your request to our Oyster network, and then Oyster executes and send it back to your smart contract so that you can verify it on chain. So everything is, the compute is happening off chain, but the verification is happening on chain, right? So that's one. And for Web2, it's pretty similar. You don't even have to do a lot of shebang like we did with smart contracts. So you can directly deploy a Node.js server. We do have a tutorial available. Or if you want to do a image build of your AI model or whatever, you can still do it, right? So build with Oysters. This is one of the exciting things. So yeah, what are we looking for, right? Any top two LLM-based applications. So we will be providing instances with both Llama 2 and Mistral being available. So yeah, you can just access that and build application layer on top of it. That's one. Second is any two DeFi applications. Again, the instances will be made available with Llama 2 and Mistral being available. You have to build on top of it. So yeah, auto contract execution when it comes to DAOs or governance. That is another thing that we are looking for. Best social application. If you are building a social engine, recommendation engine, yeah, you can do that as well. So the fifth one is a creative application, NFT, or anything that you want to do on the creative AI side. Yeah, that is also something that we are looking for. And finally, if you want to build and deploy your own AI model, as in you have your own AI model and you want to make it private and keep it secure, you should be able to do so, right? So the model weights and everything is pretty much private to anyone outside of the enclave except you, right? So yeah, these are the 6 different streams. My recommendation is whatever you are building, just deploy it on Oyster, right? Because it's pretty much whatever you are building, think of us as a equivalent to an AWS, but much more secure. So you have Ts and everything. So whatever application that you are building, my recommendation is just to optimize for your bounties, just deploy it on Oyster. Yeah, Ahmed. Feel free to do everything, right? I mean, we are not restricting at this point, but yeah, we just want folks to participate and explore the platform. So yeah. Resources to build. This is something you would want to know. So we have our docs, everything is up to date. You can just head over to docs.marlin.org. There is a section for Oyster. You will find all the tutorials within instances, how to deploy Llama and everything. So yeah, and then instances, like I mentioned, you have Llama and Mistral pre-deployed, will be made available to you. You can build on top of it. Then tutorials is also part of our whole doc section, wherein you can see how folks have deployed a JS server or how folks have deployed a Llama. In terms of support, our Discord is pretty active. We do have created a dedicated channel for hackathon. Head over there, post your queries. Team is pretty much active to support. And also our Telegram is also super active. So yeah, just head over to either of the channels, ask your questions. We are happy to help. And yeah, I'm also here. So yeah, if you want anything specific, happy to answer those. So yeah, that's it. We are Marlin. We are building the trustless coprocessor. Cool. Thank you. Thanks everyone. Yeah. Yeah, we have. Sorry. So we do have a remote attestation. So whenever a code executes inside an enclave, you get a remote attestation which says that this specific code has been run inside an enclave. So yeah, that is available, and then you can take that verification. I mean, you can take the result along with the remote attestation, and then you go back to on-chain and verify whether it's the right thing or not. So yeah, cool. Any other questions? Nope. You're good. So, anyone who wants to decentralize their infrastructure, they can work with us, and anyone who wants to build complex tasks or complex problems, they can use Oyster. So yeah, anything pretty much about complexity and also decentralization, that's where we come into picture. For example, if there is a DAO which don't want to manage the whole website themselves, they can just put it on Oyster and ensure that everything is decentralized and taken care of, right? And given that you are building the enclave image, it ensures that there is no tamper proof, right? No, I mean, it's pretty much impossible to decrypt an enclave image, right? Actually, a few other use cases of Oyster were we were able to build the whole decentralized gateways for Bonfida, similar to e.limo. We also have Bonfida, and also we built the same thing for Space ID as well, right? So decentralized gateways is one of a prominent use case. Decentralized front ends. You have a website, you pack it, and you just put it out so that you don't have to manage the whole DevOps aspect of it, right? Or you want your DAO to manage your website, you just create an enclave image and you put it out there, right? And when it comes to AI applications, I mean, it's totally up to your own imagination, right? Given that Oyster can pretty much handle heavy computations, you can, I mean, it's totally up to you what you can want to build, right? Some of the cool things that folks have built is a private private prompt as a topic. So if you are a user and you care pretty much about your privacy and you don't want anyone to look at into your prompts, you can ensure that the encryption happens at the source, and the final result that you get is also encrypted, and you need to decrypt it, right? Pretty good use case for healthcare, in my opinion, because there you are working with very sensitive data. So yeah, that can be one of the things. Even for financial models, right? Say, Cameron, you have a pretty slick strategy which you don't want anyone to be aware of. You can pack it and put it in an Oyster, and when the time arrives, it will just trigger a smart contract and everything gets executed. And everything is in a black box, right? Only you are the only person who knows what you have set it to be. So yeah, and in AI, like I said, you can develop your own models, you can deploy them on Oyster. So yeah, yes. So it's not a GPU, it's a CPU only, but we were able to run Llama 2 and Mistral with that, and very little to no latency. And in terms of GPUs, we are not there yet, but yeah, we are in the process of procuring GPUs. Sorry? No, not exactly. I mean, we were able to run Llama to the 7B model, and we were able to do everything as it is. There are a couple of smaller restrictions, workarounds. So, for example, the enclave image can't be beyond 1 GB, right? So, there is a way to work around that, which is made available in our docs. So, yeah. Cool. Yeah. Yeah, go for it. Sorry? We are quite a small and decentralized team. I mean, we are about what, 12 to 15 folks, pretty much decentralized, spread across Asia, North America at this point. So we were part of the Binance Accelerator season 2. So yeah, been around the block for some time. So yeah, and we are also backed by Electric Capital. Yeah. No, it's a DAO. It's not like, I mean, there's a foundation that takes care of everything. So, I mean, it's not only, I mean, the foundation is the central entity which ensures that the funds are not being misused and everything is happening the way it's supposed to be. Yep. Cool. Thank you. Thanks a lot. Thank you.